Alright guys, so now we are going to talk about, let me go back to the beginning, which is the section 4.3, graph of the tangent and cotangent functions. The methodology that I showed you in the previous section 4 and 4.2, we can also use it for the section 4.3. The only difference is when you are dealing with a tangent or cotangent, you're dealing with a fraction, therefore you have a denominator, and therefore you know that when you have a denominator, this one cannot be equal to 0, and that will define your asymptote, your vertical asymptote. So let's work this out with the first graph, which is the tangent x, which is sinus x over cosinus x. So the first thing I want to do is looking at my denominator, and I see that my denominator is cosinus x, and I want to define that if cosinus x was equal to 0, that means that the angle x will be equal to pi over 2. So you have a vertical asymptote at x equal pi over 2. But you know also that the cosinus x is equal as to 0 when your angle is also equal to 3 pi over 2. So you know that at x equal pi over 2, you have a vertical asymptote. So at x equals pi over 2 or 3 pi over 2, you have a vertical asymptote. And basically, here we go. And so I can see that there is a value of pi in between the two asymptotes. So by symmetry, I can have at minus pi over 2, I will have another asymptote. And at minus 3 pi over 2, I will also have a vertical asymptote. So now, let's try to find where are the zeros of that function. The zero of that function, the zero of f of x, are the value of x, that make your function equal to 0. Well, the function tangent x will be equal to 0 if, and only if, the sinus of x will be equal to 0. And sinus x equal to 0 when x equals 0, when the angle, the sinus of the angle equal to 0, when the angle equal to 0, in that case x is the angle, when the angle is equal to pi, or when the angle is equal to 2 pi. So now I know that the zero of my function is when x equals 0, when x equals pi, when x equals 2 pi, and by symmetry, I can fairly say when x equals negative pi and when x equals negative 2 pi. These are the zeros. So to find the other value, how can I define if my function is going this way like this or if it's going this way? Well, that's pretty easy. What I'm going to do is I'm going to take a value of x. And which value of x I'm going to decide to take? Well, I'm going to take pi over 4. Why do I take x equal pi over 4? Because it's just half of the value that I have right here between 0 and pi over 2. I can fairly take x equal pi over 4. So if x equal pi over 4, tangent pi over 4, because I know my angle equal x, so tangent x equal tangent pi over 4, will be sinus pi over 4 divided by cosinus pi over 4. When I look at the trigonometric circle, the sinus pi over 4 equals square root of 2 divided by 2, and the cosinus pi over 4 equals square root of 2 divided by 2. So when I substitute the sinus and the cosinus in this function, we got square root of 2 divided by 2 divided by square root of 2 divided by 2, and we got 1. So when x equals pi over 4, I am right here. So I can fairly say when the x equals negative pi over 4, I will be at negative 1. Okay, negative 1 being right there. And so now it's pretty easy for me to say, okay, tangent x, it is something like this. Roughly, I can graph my tangent. Okay? So as you can see, it's not very complicated. The period is pi. The period is pi. And when you look at between this point and this point, or any point in between on each graph, you will find a period equal pi. If you look between this point and this point right here, you will find pi. Do you need to remember that? I don't think you need to remember that because you know how to graph your function very quickly. The x-intercept occurs at n pi. I don't think you need to remember that. You can find that very quickly. It takes like 30 seconds, not even. All right, so now if I want to graph cotangent, cotangent is going to be exactly the same idea. If I look at cotangent of the angle x, basically it is cosinus x over sinus x. So in that case, the denominator is sinus of the angle x, and my denominator will be equal to 0 if the angle x now is equal to 0, if the angle x is equal to pi, or if the angle x is equal to 2 pi. The sinus will be equal to 0. Sinus cannot be equal to 0. That means we're having vertical asymptote at x equals 0, x equal pi, and x equal 2 pi. So at x equal pi, I got a vertical asymptote. At x equal 0, I got a vertical asymptote. At x equal 2 pi, I have a vertical asymptote, and by effect of symmetry, I can fairly say at minus pi, I got a vertical asymptote, and negative 2 pi, I got a vertical asymptote. Now, if I want to look at the value of my cosinus, well, I'm going to take a value of x, and I'm going to take a value of x equal pi over 4. So I'm going to take x equal pi over 4, and what is the value of my tangent? Well, at the value of x equal pi over 4, because x is the angle, basically I'm looking for tangent of pi over 4, which is cosinus pi over 4 divided by sinus pi over 4. Based on the trigonometric circle, I know that it is equal to square root of 2 divided by 2 over square root of 2 divided by 2. And at x equal pi over 4, I know that I'm supposed to be equal to 1. So very quickly, because I do have to remember the shape of a tangent, I can fairly say that at 3 pi over 4, I will be at negative 1. Therefore, I'm expecting to have... I'm sorry, but I forgot to calculate when it will be equal to 0. I can almost envision that it would be at pi over 2, but when do we have the tangent, of my angle equal to 0? Only if the cosinus of the angle, in that case x, is equal to 0. And I know that the cosinus of the angle equal to 0 only if the angle, in that case x, equal to pi over 2. So I know, pi over 2, but also x equal 3 pi over 2. You have understand that. So obviously I know that my 0 is at pi over 2, 3 pi over 2, and I can fairly say also at negative pi over 2 or negative 3 pi over 2. And now if I can graph my function, I can fairly graph my function like this. And now I have a pretty good shape, pretty good sketch of my cotangent. The period is pi. If I look in between this point right here and this point right there, I got pi. No need to remember that. I don't think so. It's necessary. I don't think it's necessary for you to remember that. Graphing your function will giving you the ability to know that very quickly. So, all right, guys. So now, if I want to look over the graph of the equation y equal tangent 2/3 of the x, applying the same methodology, my denominator cosinus 2/3 of the x could be equal to 0, but I know it cannot, and that will define my vertical asymptote. I will have two vertical asymptotes, x equal 3 pi over 4 and x equal 9 pi over 4. By effect of the symmetry, I can find the other one, which is the one at minus 3 pi over 4. Where there we have a 3 pi over 4 and minus 3 pi over 4 is right here. Then I'm going to look for the zeros, and my tangent will be equal to 0 if my numerator now is equal to 0, and that will define different value of x equal 0, x equal 3 pi over 2, and x equal 3 pi, because I know that my sinus will be equal to 0 when the angle 2/3 of x equals 0, pi, or 2 pi. And that implies 0, 3 pi over 2, and 3 pi. So when I'm done with that, I'm going to look for, so I'm plugging my 0, of course, right here in purple. And then what I need to do is I need to take a value of x, and I decide to take a value of x equal pi over 4. And what would be the value of my tangent 2/3 of x when x equal pi over 4? 2/3 of pi over 4, it's pi over 6. When I substitute the value of sinus pi over 6 and cosinus pi over 6 with my the trigonometric circle value functions, I'm going to find a value of square root of 3 divided by 3, which is the rationalized expression of 1 over square root of 3, which is about 0.577. So I know that I'm supposed to have a point somewhere like this, and I can fairly say that I can expect something looking like that for this function. Alright guys, so on the problem number 2, negative 1 over 2 tangent 2x, we apply exactly the same idea. We're looking first for the vertical asymptote. We have a tangent. The denominator is cosinus. So with the cosinus 2x equals 0, we define the asymptote. And then we are going to define the 0 of your function. We're looking for the 0, which means we're looking for the value of the angle that makes your sinus equal to 0, because the only way that the tangent 2x equals 0 is that the numerator is equal to 0, and the tangent, the numerator, is sinus. Once we have the zeros, we decide to take a value of x. By the way, if you look at your graph, I decided to change a little bit the scale because it was too tight. And so I decided to represent the scale the way it is. So please follow the scale that I just represented right here. And I decided to take x equal pi over 8, which was the half of between 0 and pi over 4, between 0 and pi over 4 right here. And I found that it was about negative 1 over 2. So when x equal pi over 8, I was supposed to be a negative 1 over 2, and that helped me to define the shape, because as soon as I knew that a point was right there, I was able to define the shape of my function y. Same idea for cotangent. First of all, please I would like to remind yourself that you need to calculate the vertical asymptote. In that case, cotangent, that means the denominator will be sinus 1 over 2x. Then you have to find the 0 of your function by looking at what would make the numerator, in that case cosinus over 1 over 2x equals 0, and then choose the value of x. So you have to do that by yourself. Finish also this one, and this one, what do we have? We have f of x equal g of x, which is tangent x, minus k, and that means we have a shift down of the graph tangent x by itself. So you are supposed to have everything but with a shift down. And I will also let you do this to the problem number 5. Same idea. We have a cotangent. You need to find the 0, the vertical asymptote, the same way I told you. You will have to find the same value, the same thing for the 0 of your functions. And then you will decide the value of x. If you have to change the scale of the graph, please do it. Don't follow necessarily this one. and everything will be okay. We'll talk about that in class. Thank you guys, and